Hello. So for this video, I want to talk about a review topic. Actually, I'm going to review circular or rotational quantities. It's important that we review this. We talked about it back in chapter 4, but I want to reiterate a few key points before moving on to the formal chapter 8 material. The reason I'm doing this is, again, we need to be thinking not just in straight lines for chapter 8, but now rotating. I want to make basically a little bit of a chart here before we get started with some equations, and just remind ourselves we have our we have our linear, we have our rotational quantities, and then we should actually talk about the quantity itself. For the first quantity, our most basic quantity is position or displacement. So I'm going to write displacement here, and then in parentheses position. When we talk about displacement, we usually write the delta symbol. So delta x is our general symbol, or delta s has been a general symbol for us in the past. To move to rotational, we think about a change of angle, right? An angular displacement, and we represent that with delta theta. We can take a derivative of these quantities. Derivative of displacement with respect to time is velocity. And so we call that v. I know all these are technically vectors, but I'm not really going to dive into all that in this video. The angular velocity we represent with omega. It's that curly little w that we've used in the past. Finally, if I take another derivative with respect to time, I get acceleration. Now, of course, acceleration is a in linear terms. We call it alpha. Oh, that's a weird alpha. Let's call it alpha. That's a weirder alpha. One more time. Alpha in angular terms. So that is our angular acceleration. How quickly am I speeding up going through an angle? It's a little bit different, though, than our centripetal acceleration, right? Whenever we are rotating, we are considering a centripetal acceleration. We write centripetal acceleration in terms of linear quantities, linear acceleration units, so meters per second squared. Anytime we rotate, anytime we go in a circle, there is centripetal acceleration, right? We can write centripetal acceleration as our tangential speed, our linear velocity through the circle, squared over the radius of our circle, r. There's another way that we can write that using omega. We can say omega squared times r now is our centripetal acceleration. Now, if we're speeding up or slowing down going through the circle, we have some tangential acceleration. Remember, centripetal acceleration is always radially inward. Radially inward. But when I talk about a tangential acceleration or an acceleration an angular acceleration, I'm talking about how fast how much I'm changing v, right? How much am I changing the magnitude of v? How much am I changing the magnitude of omega? That is, if I have some tangential acceleration or angular acceleration, my centripetal acceleration is going to be changing the entire time I'm speeding up or slowing down there. Centripetal acceleration just changes the direction of the velocity vector. It doesn't change the magnitude. How do we go from delta x to delta theta, or v to omega, or a to alpha? It's usually just through the radius. So if I think about delta x or delta s divided by r, that would be my angle, theta. So maybe I should actually write that as a delta theta. I can think about v, my velocity, divided by r, and I would get omega. And likewise, I can get alpha, I can get alpha from my acceleration, my tangential acceleration over my radius. So this is how we can go back and forth between our linear and rotational quantities. The only other thing I want to point out is that we've mentioned in the past that our velocity can be also thought of as the total circumference, 2 pi r, over this quantity called the period. Right? How long does it take to go around in one full circle, one full rotation? We label that capital T. Another way of writing the period, if we know something about, let's say, the rotational speed, would be that it's equal to 2 pi over our omega. So that is a brief review of rotational quantities and how to use them. I'm going to start talking about uniform circular motion and how we can add forces into that in the next video. So stay tuned. Thank you for watching and have a good day.